Okay, so imagine you're in a spaceship. Not some sci-fi movie nonsense, a real one. And your captain looks at you and says, "All right, we're gonna hit the gas and break the speed of light." What happens? Nothing. Seriously, nothing. You don't go faster. The universe literally stops you. And it's not because of some cosmic speed bump or a bouncer at the edge of reality. There's actually a reason, and honestly, it's way cooler than you think. Here's the thing nobody told me when I first learned about this, and I was genuinely pissed off when I found out. The speed of light isn't actually about light. Weird, right? It's not like light decided to be the fastest thing and everything else just respected that. No, it's way deeper. The speed of light, about 186,000 miles per second, that's not a speed limit that light imposed. It's a fundamental property of space-time itself. It's literally written into the fabric of reality. Think of it less like a speed limit on a highway and more like the maximum volume your speakers can produce. You can't go past maximum volume. It doesn't exist. And that's what the speed of light is. It's not a barrier you're trying to break through. It's the absolute maximum of what's physically possible in our universe. So here's where Einstein comes in. And look, I'm not going to pretend I understand all of his math. I don't. Nobody really does. But the core idea? It's actually beautiful. Einstein figured out that time isn't constant. Let me say that again because it's wild. Time isn't constant. It changes. It moves slower when you go faster. It moves slower when you're near something really heavy, like a black hole. And he also figured out that mass and energy are basically the same thing. E equals mc squared. That equation? It's saying that even a tiny bit of mass contains an absolutely insane amount of energy. Now here's where it gets relevant. When you try to accelerate something, anything, you need to give it energy, right? Push harder, go faster. Basic physics from high school. But the closer you get to the speed of light, something crazy happens. You need more and more energy to go even a little bit faster. It's like the universe is putting up resistance. At 50% the speed of light, you need a certain amount of energy. At 90%, you need way more. At 99%, you're talking about needing insane amounts of energy. By the time you're approaching the speed of light, you'd need infinite energy to push you those last few miles per hour faster. And guess what? We don't have infinite energy. And we never will. Let me give you some real examples because this isn't just theory. There are actual things in the universe that prove this. First one, electrons in particle accelerators. Scientists have these massive facilities. We're talking about machines that cost billions of dollars, where they smash electrons together at insane speeds. We're talking about 99.9999% the speed of light. These things are flying. But here's what they observe. No matter how much more energy they pump in, they can't get it to actually reach the speed of light. It just gets closer and closer. The electron gets heavier. Yeah, heavier. Not in the way you're thinking. It's relativistic mass. The effective resistance to acceleration increases. And the faster it goes, the more energy you waste just trying to get it slightly faster. It's like pushing a boulder up a hill, and the closer you get to the top, the steeper the hill gets. Eventually, you run out of strength. Second example, time dilation. This one will mess with your head. There's a subatomic particle called a muon. In a lab, a muon lives for about 2.2 microseconds. That's 0.0000022 seconds. Incredibly short. These muons are created constantly in Earth's upper atmosphere when cosmic rays smash into it. And when they're created, they're moving at about 99% the speed of light. Now here's the problem. They're created 15 kilometers up in the atmosphere. And they only live for 2.2 microseconds. So theoretically, even traveling at near light speeds, they should only travel about 660 meters before they decay. But scientists detect them on the ground, at sea level, 15 kilometers down. How? Time dilation. From the muons perspective, because it's traveling so fast, time moves slower for it. So from its point of view, only a fraction of that 2.2 microseconds has passed when it reaches the ground. It makes the journey because time itself moves differently at those speeds. This is real. We measure it. We use it in GPS satellites. We have to account for time dilation, or your GPS would be off by kilometers in just a few days. Third example, light from distant galaxies. When we look at distant galaxies through telescopes, we're literally looking backward in time. The light left that galaxy billions of years ago. Even though light is traveling at its maximum speed, it still takes billions of years to reach us. Why? Because space is just that big. There's no way to shortcut it. Even at the fastest possible speed, distances are so enormous that it still takes forever. This is the universe telling us, yeah, speed of light is the limit. Accept it. Plan accordingly. Here's another angle that blows people's minds. Relativity. Let's say you're in that spaceship again. You're traveling at, let's say, 90% the speed of light relative to Earth. From your perspective, you're just hanging out. You're moving at a normal speed. You feel normal. Everything inside the ship feels normal. But someone on Earth? They're watching you move at 90% light speed. Here's the wild part. Both perspectives are correct. That's not me being poetic. That's actually how the universe works. Now imagine you somehow managed to travel at the speed of light. What would that mean? From your perspective, you'd still feel normal, right? But from an observer's perspective, you'd be moving at light speed. But here's the thing. Time stops at light speed. Literally. For a photon, a particle of light, time doesn't pass at all. From a photon's perspective, no time elapses between being created and being absorbed, even if it travels across the entire universe. You can't be in a state where time is stopped and also be conscious and observing things. You can't go faster than light because you can't exist in that state. The universe has essentially written into its rules, sorry buddy, you're not allowed to be a photon.